Let's look at the connections to dash module number 5. As with all the modules, we have a D-type connector. In the case of DM5, that's a 15-way D-type connector. And we also have a set of terminal block connectors. The terminal block connections are numbered from right to left, looking at the back of the unit, so that's pin 1 at the right side and pin 37 at the left side. The pins on the D-type socket on the board are numbered right to left on the socket, so that's pin 1 at upper right of the socket. And of course on the plug, they're numbered from left to right, so that's pin 1 at the upper left of the plug. Let's start then by looking at the essential connections to the module. In the case of the power supply, there's an ignition switch power supply which goes in on pin 1 of the D-type connector, or alternatively pin 1 of the terminal blocks. The ground return for the power supply goes in on pin 15 of the D-type connector, or alternatively pin 2 of the terminal blocks. Also on this module, let's start off by looking at a number of ground switched discrete signals that are connected to the unit. Now these pairs of indicators here are green at the top and red at the bottom, and these are driven by ground switched discrete inputs. We have them set up by default so that when the corresponding input is open circuit or not connected to anything, these indicate red, and when the corresponding input is connected to ground, they indicate green. I might actually switch that or provide an option. Let us know what you think, so that the indication is red when the corresponding input is grounded, because we tend to use these inputs for warning functions, such as we use the left-hand one as the check engine indication. We use the second one as the brake indication to indicate the park brake is on or there's a problem with the hydraulic brake. The third one as the park neutral indication. And the fourth one is a spare, which you can use for any ground switch discrete input that you like. These indicators at the bottom, these three, normal, auto and pursuit, are also ground switch discrete inputs. And when the corresponding input is grounded, these pairs of indicators illuminate. This power input is actually driven by an onboard voltage monitor, so that if the voltage goes out of range, this power indication flashes. If it's in range, it'll be on constantly. The best place to pick up the connections from the car to drive the first two of these ground switched indications is from the stock dash connectors behind the stock instrument cluster, the dash connectors behind the stock instrument cluster. So let's take a quick look at where those connectors are and how they're numbered. Now if we remove the instrument cluster, the stock instrument cluster, we're going to see two 14-way connectors, a black one at the top and a white one at the bottom. This is a photograph that I took from an 82 or an 83 car, and in fact I think the connectors, this pinout applies to cars between 82 and 85. Here's another photo of the same connectors but on a car a bit later, I think about 86, an 86 Firebird this was, and you can see that there are different pins fitted, and it turns out that the connections to them are significantly different. There could be other configurations as well, but as far as I'm aware, there are only two main configurations that I'm aware of. The configuration that we see on the left for 82 to 85 cars, and the configuration that we see on the right for 86 through 92 cars. The connector's pins are numbered as shown. The upper connector starts with pin 1 at the upper right, and the pins are numbered counterclockwise around the connector. The lower connector is numbered with pin number 1 at lower left, and again numbering counterclockwise around the connector. We've just put some labels on here to show the functions of the known pins on these connectors. Those little arrows represent whether the signals are inputs or outputs, and apart from the pin 6 on the early cars, everything is an input. That pin 6, as we mentioned earlier on the earlier cars, is actually an output of the VSS signal from the dash, generated by a module on the dash, out to the ECM for it to control the torque converter lockup. You'll notice that there are a few connectors that I'm not sure of the function of. That is pin 5 on the lower connector of the early cars, and pins 4, 5 and 6 on the upper connector of the later cars. So if any of you have clues as to what those do, please let us know. Finally, just to point out that the lower connector is designated C1 and the upper connector is designated C2. The connections for the check engine lamp can be picked up from pin 14 of the upper connector C2 on the earlier vehicles, or from pin 13 of the upper connector C2 on the later vehicles. That check engine indication is fed into the module on pin 5 of the D connector, or alternatively pin 16 of the terminal blocks. We also have a brake indication, which is also a ground switched discrete input and is grounded either when the park brake is on or when there's a problem with the hydraulic brake. So let's look at where we pick up that signal from. The connection for the brake signal can be taken from pin 6 of the lower connector C1 on the earlier vehicles, or from pin 1 of the upper connector C2 on the later vehicles. And that brake signal is connected on pin 6 of the D connector, or pin 17 of the terminal blocks. The park neutral indication is another ground switched indication, which is grounded when the automatic transmission is in the park or neutral position. That connection to the park neutral will be picked up from an orange wire coming from the automatic transmission shifter. And that ground switched discrete goes in on pin 7 of the D connector, or pin 18 of the terminal blocks. Finally, the right-handmost green-red indicator pair is driven by a signal which goes in on pin 8 of the D connector, or pin 19 of the terminal blocks. Now we also have these pairs of indicators, which are ground switch discretes: normal, auto and pursuit, and the connections to those go in on the following pins. The normal signal, the ground switch discrete that we need to illuminate the normal pair, goes in on pin 2 of the D-type connector, or pin 12 of the terminal blocks. The connection for the auto indication on pin 3 of the D-type connector, or pin 13 of the terminal blocks. And finally, the connection to illuminate the pursuit pair goes in on pin 4 of the D-type connector, or pin 14 of the terminal blocks. We also have connections for a couple of analog inputs to drive these three gauges, these three 5 element 5 LED gauges, with corresponding diagnostic LEDs above each one of the gauges. Now we connect those to a throttle position sensor and an air temperature sensor. The upper gauge we actually drive from an onboard voltage monitor, so this will indicate the voltage, the supply voltage to the unit. The middle gauge we connect to a throttle position sensor, and we recommend you use a separate throttle position sensor. Don't use the one that's connected to the ECM, it may cause problems with the ECM operation. And the bottom one we use to indicate the air temperature sensor. Again, we can connect an external air temperature sensor for that. So let's look at the connections that we need to go in to drive the throttle position sensor and the air temperature sensor. Again, these aren't something that you can pick up from the stock dash connectors, so we'll need to provide separate connections for those if they're going to be used. If you don't want to use them, we can configure the software to just operate those gauges in a show mode. So, regarding both of those sensors, both of those sensors require a 5-volt reference signal, and we have a 5-volt reference signal produced by the board and sent out via this second fuse, fuse 2, which is a small 200 milliamp fuse. That goes out on pin 9 and 10, which are both connected together, of the D-type connector, or on pin 34 of the terminal blocks. The signal connection from the TPS throttle position sensor goes back in on pin 11 of the D connector, or pin 35 of the terminal blocks. And the signal from the air temperature sensor goes in on pin 12 of the D connector, or pin 36 of the terminal blocks. Also, you'll see that we have an onboard speaker on this module for generating audio tones, warning tones. If you want to use that onboard speaker, then we need to put a small link between pins 26 and 27 of the terminal blocks. Alternatively, you can use an external speaker of 8 ohm impedance, and if you want to do that instead, remove this small link between pins 26 and 27 and connect the high side of that external speaker to pin 26 and the low side of that external speaker to pin 28. We also have connected on this module a number of pins which aren't essential to use but are recommended if you want to get the maximum functionality from the module. And those are a number of ground switched discrete inputs connected to push buttons and a latching switch labelled SW1, and the momentary contact push buttons numbered, designated PB1, push button 1 and push button 2. Also a couple of potentiometers for controlling the brightness of the displays. The potentiometers are connected as follows. Potentiometer number 1, which controls the brightness of the numeric display. We'll look at that in a moment. We'll actually power it up and look at that in a moment. But potentiometer number 1 is connected as follows. The pot is connected on pin 13 of the D-type connector, with the other side connected to ground, or alternatively it can be connected between pins 22 and 23 of the terminal blocks. Potentiometer number 2, which controls the brightness of everything else, can go in on pin 14 of the D-type connector, with the other side connected to ground, or be connected between pins 24 and 25 of the terminal blocks. The momentary contact and latching push buttons, the common side of all of those connects to pin 37 of the terminal blocks. The latching switch SW1, which is the yellow wire, connects to pin 11 of the terminal blocks. Push button number 1, which is the yellow wire, connects to pin 9 on the terminal blocks. And push button number 2, which is the blue wire, connects to pin 10 of the terminal blocks. We also have a module reset, which isn't connected on here, which enables you to externally reset the module, and that can go in on pin 20 of the terminal blocks, with a convenient ground return on pin 21. Also available is an RS232 serial communications bus, which we're going to provide more functions for as we upgrade the software in the future. And the receive side of that goes in on pins 29 and 30 of the terminal blocks. That's signals going into the module. And for signals coming out of the module, that's the transmit side, connections are on pins 31 and 32 of the terminal blocks. There are also a number of spare discrete inputs which aren't used by any default software at the moment, but which we can configure to custom versions of the software. And we have two low-side switched discrete inputs, which go in on pins 8 and 15 of the terminal blocks. 4 high-side switched spare discrete inputs, which go in on pins 4, 5, 6 and 7 of the terminal blocks, and another spare input which can be configured as a low switch discrete or even as a frequency input, and that's on terminal block pin 33. So before closing this video, let's just power the module up and have a quick look at the functions. Neil, you've done it again. You've not connected it up. So let's plug in power and try again. You can see that, as on all the units, when we first power the module up, the 4-digit display momentarily indicates the version of software being run. In this case it's 0.03. We have a voltage, supply voltage. We'll see that it says 13.1 U because with these 7-segment displays you can't actually display a V for volts, so we've used a U instead. So that's a supply voltage. Supply voltage, as we said, is also indicated on this upper bar gauge. Now when we take the voltage out of range, if we take it out of range low, below about 10 volts, you'll see we'll get an under voltage indication, and the under voltage indication is indicated by a flashing diagnostic LED on the upper gauge and a flashing indication on the power pair. Let's bring the voltage back into range, and that bar gauge is configured such that each LED corresponds to an additional 1 volt. So 11 volts, when you're above 11 volts the first LED will come on, 12, 13, 14, 15. And we can just bring the power up, bring the voltage up, 13 volts, 14 volts, 15 volts is out of range again on the high side. So again we get a flashing indication on here and on the power LED. Let's bring that back down to some voltage more realistic of the power supply on the car, and we can see these indications here. The normal and auto are ground switch discrete inputs. The pursuit is a ground switch discrete input. This gauge is the throttle position sensor, and we have out of range indications on there as well, so that if it's right above the valid range of the sensor it'll indicate a fault. Below the valid range of the sensor will indicate a fault. We have an air temperature sensor. Now the air temperature sensor might actually need to be calibrated to the specific vehicle in use. So custom version of software might be required for that once it's installed on the car. These red-green indicators, as we said, correspond to ground switch signals. Check engine light. Well, we've got it configured right now so that when that goes ground, which is active, it goes green. So if you want that the other way around, let us know and we can configure that the other way around. They're all ground switch discrete inputs. This 4-digit display can also be set to other functions instead of voltage. Like, for example, these are spare inputs that are available on the serial bus. That's direct display access and a show mode. And this with the P after it is an indication of throttle position sensor. So throttle position sensor can be on this, is always on the center gauge, but can also be configured to show a percentage as a numeric display. And also the temperature can be shown on there. Again, we say we might need to calibrate that to the specific vehicle. But by default we tend to set this up as a voltage indication. And that, I think, covers the connections to DM5, except to say that, as on all the modules, we have a 6-way connection, a 6-way plug. By the way, don't touch the regulator when you had it running, because that is intended to get hot. There's a little heatsink on there. There's a 6-way connection on here, which is an in-circuit serial programming connector to enable updates of the software via what we call a PIC kit, which is something produced by Microchip, the manufacturer of that microcontroller, to enable upgrades of the software.